We have the Moonies and the Loonies and the Flat Earthers, okay? What are the Flat Earthers? Well, people who say that we've never went to space, because if we happened to go into space, we could have very easily taken a picture or filmed, the Earth from afar, and we would know if it's round, if it's flat. We would know if it's spinning. We would know a lot of stuff, right? Just by looking at the movie. And a human doesn't have to go up there. We could do it with, just a satellite or whatever. And then we have the Moonies. The Moonies say we never went to the moon. Okay. And you have all kinds of ranges there. Some people say we haven't even gone into space. Others say we haven't even gone to the moon. And obviously, if that's the case, we'll never go to Mars, because some people believe a human cannot escape the Earth and live, partly because of radiation, partly because of vacuum. And then you have the Loonies, and we're going to deal with those today again, one more time. For those of you who have something better to do, well, don't do it. Just stick around, and you might learn something. And so you have these Loonies, and they believe that the moon spins. And no, we're going to argue that the moon does not spin, okay? Okay, so let's start with this fellow. We're going to start with some of the comments, questions people made, and they're all related to these Loonies that believe that the moon spins. Okay, here's the first one. It says, the moon spins, and said nothing else. Okay, it'd be nice if you say a little more than justify that the moon spins. That's a lot harder. And so to say and make a statement that the moon spins, you said nothing. Okay, nothing that concerns science, at least. Okay, another fellow says, the moon has an axis that rotates with it, so the moon doesn't spin. Earth's axis doesn't rotate with the planet, so it spins. And he was essentially saying repeating what I said, and he said it correctly, so I hope he understood it, and I hope everybody else understands it. And there's an illustration of that. The moon spins together with its axis, and I put a three-dimensional axis there, so you understand the concept. That's what we're looking at here. We're not interested in belief. We don't care if you believe in this or not. It's irrelevant. Right now, we just want you to understand the concept. The concept is that if the moon spins, what we're saying is that the axis that runs through it does not spin. But if it spins, like in that case, together with the moon, then the moon is not spinning, because any point on the surface is not changing its distance with respect to that three-dimensional axis. On the other hand, in the case of the Earth, it's as if we had a solid, fixed, standalone, unmovable axis, three-dimensional axis again, and the surface moves and changes its distance with respect to each point on that axis. Okay, so that's the concept. That's the definition we're going to go with. Okay, if you don't like it, all you got to do is bring your definition, and hopefully you address the issues that will be talked about today. Okay. Okay, so here, fellow said it correctly. I hope you understood more or less what I'm saying. Okay. Another fellow says, okay, he says, it's quite confusing. It's quite a confusing analogy. Yeah, he's quite confused, no doubt about it. It says, is it not the case that the moon has ice caps top and bottom? Okay, that would mean that it spins or not spins in relation to the sun as well as the Earth. Well, I'm not sure what the fact that it's got ice caps has to do with the sun or the Earth. He hasn't made his point. Okay, and isn't the moon just tidally locked with the Earth in the first instance? Well, let's find out. What is this tidally locked? We have no idea what this is. Okay, let's find out. It says, tidal locking between a pair of co-orbiting astronomical bodies occurs when one of the objects reaches a state where there is no longer any net change in its rotation rate over the course of a complete orbit. In other words, you have a rotating body. Let's assume at some point the moon spun around, and over the millions of years, slowly it slowed down until it finally gave a single face to the Earth, and it no longer spun. Okay, and so now it's tidally locked because it doesn't spin. Yeah, that's the issue. But the interesting part also related to that is high tides and low tides are caused by the moon. Okay, and the moon's gravitational pull generates something called what? The tidal force. Newton discovered or theorized that the moon affects the tides on Earth. Okay, and well, it goes on and on, but this is the issue. Here's the Earth and here's the moon. Okay, and the question there is, what causes the tides? If the moon is 380,000 kilometers away, how does the moon affect the tides? How does the Earth compel the moon to have this what is it? The fact that it's tidally um, uh, locked. In other words, how does the moon affect the Earth physically, and how does the Earth affect the moon physically? If you don't put something in between there, then you're doing your theory with ghosts and with angels. Okay, that's what it is. You're doing black magic. Hopefully, if you're going to talk about tidally locked or tidally anything, the moon affecting the tides on Earth, hopefully you can tell us the mechanism, and you can tell us how one object affects the other through 380,000 kilometers of distance. Okay, and you can't use concepts. That's even worse. You might as well use ghosts and angels. Okay, so again, anyone who uses these notions of tidally locked and says that the moon affects the tides on Earth and that kind of thing, no problem. I think they do. The question is, what is the mechanism? If you can't tell me the mechanism, don't just say things that you read about or copied and pasted from the Wikipedia or whatever and say, oh, see, it says tidally locked here. Yeah, explain why. Explain the cause, the mechanism. Then you can talk about tidally locked. Okay? Otherwise, don't mention it. Okay? Don't say that mass did it or energy did it or a field or a force. Time. Okay, and then says a better analogy might be the rotor in an electric motor as it has in a shaft to rotate about. And I discourage the use of the word rotate. Okay, because rotate is ambiguous. You can rotate around a planet, meaning you orbit it, and you can rotate around your axis, meaning you spun or you're spinning. And so the question is, whether we should use the word rotate, which is so ambiguous. And I'm going to encourage everyone to use the word spin or orbit, because those are very clear cut in the minds of most people out there. Orbit is what you do around something else. Spin is what you do around your own axis. Okay, and so I'm going to stick to spin and orbit and stay away from the word rotate, which is what is confusing this fellow up here. Okay, it's the confusion comes from using synonyms which have never been defined. In fact, none of these words have ever been defined scientifically, and that's what we're going to talk about in a minute here. Okay, it says you go on, another fellow. You go on about defining axis as being a 2D, 3D object made up of two spatially abutting, non-coinciding planes, which you call edges, when all this has nothing to do with why you believe moon actually rotates with its axis, whereas Earth does not. Well, the first issue we have to look at is this word believe. We have nothing to do with belief. This is not about belief. This is explaining a mechanism based on a definition, because we're trying to justify the definition. And what we're doing here is, just putting a definition and arguing the fact that spin has to do with a fixed axis. That's how we're defining it, and that's the definition we're using to explain this phenomenon known as spin. Okay, and so I'm giving you something objective. If you don't like it, you got to come back with an objective definition and argument. Not say that we have a belief. There is no such thing as belief in science. Okay, so this word belief should exit your mouth and your brain. You should come into science talking about objective explanations, objective mechanism, objective causes. That's what this is all about. Okay, and yeah, I'm gonna go in a minute again of why we use this 2D or 3D axis. Okay, and I'm gonna get that in there in a second. Okay, but here you see essentially why we need that axis there. Okay, and why we need anything other than a one-dimensional axis. But the problem here is this word rotate, which is equal to spin. It's also equal to orbit, and also equal to every other word like spiral and so on. So rotate is a word that we do not want to use. Let's use spin and let's use orbit. What is spin? Spin is circular motion of an object's surface with respect to what? Its fixed axis. The axis has to be fixed. Okay, and in the case of orbit, it's the circular elliptical motion of a body around another. Okay, so these are different. So if you look at the guy in the first, the guy who's walking around in circles there, is he spinning? Well, no, he's orbiting. He's not spinning. Okay, why? Because he is not spinning with respect to his own axis. Okay, and so the question is his axis standing still or not? Is it moving with him? And right now we have no indication that it is standing still, and we have no indication that it's moving. And I'll tell you why in a minute. Okay. On the other hand, the fellow on the right looks like he's spinning, but again, we won't know, the guy in the center, because we don't know if his axis is standing still or not. Okay. And again, that's going to be the argument, whether the axis is standing still, whether it's moving, whether it's fixed or rotating together with the object. Okay, and people say, "Oh, what are you talking about, Bill?" Okay, let's find out. Here we have one more fellow. He pointed out something related to this, and he said, "Points and lines are axiomatically defined by their what? Parameterization. Here lies the rub." Okay, so when you look at parameterization, process of finding parametric equations of a curve, a surface, or more generally a manifold or a variety defined by an implicit equation. What is a parameter? A constant or a variable, a numerical or other measurable factor. In other words, he's saying that points and lines are defined by equations, numbers, variables. No, not in science. Okay, maybe in mathematics. Maybe that's how they define things there, which is not a definition at all. So no, it's not defined through parameters or anything related to equations or numbers or variables. That's exactly the problem. You end up with situations like in quantum mechanics where they define spin and they say, well, it's minus half spin or one spin or plus half spin. What do you mean minus half spin? What the hell is that? I thought spin was spin was spin. And it turns out that spin is a number, one of these quantum numbers. And so, no, we don't define spin with numbers. Not if you're later on going to insinuate that that means that the thing is spinning like a top. One thing has nothing to do with the other. The fact that a top spins has nothing to do with the notion of spin, for example, for an electron. When they talk about electron spin, they're not talking about it spinning, the notion of spin that we normally have, right? We're talking about orientation. When you measure at that point in time, it's got a given orientation. That's what they say. And the orientation is either up or down. So what kind of spin is up? What kind of spin is down? What kind of spin is minus half or plus half? And again, this is the problem. We do not use numbers to define spin. The other thing is that you should be aware of is that spin is a physical phenomenon. It belongs exclusively to physics. In mathematics, there's no such thing as spin. They have no use for the word spin in mathematics, pure mathematics, okay? Now, the problem is that the mathematicians, they started venturing into physics. And so they created this religion known as mathematical physics. And that's when they put numbers together with things, concepts together with objects. And they blended them together and created a big mess. And we've had this big mess at least since the days of the Greeks, and it hasn't stopped till today. So, you talk about a singularity, like a black hole singularity, and you say, okay, I know what a singularity is. It's a little dot. No, a singularity is a number. Okay, it's a number. That's what a singularity is. It's got to do with equations. It's got nothing to do with a dot, for example. Okay, again, that point, the word point, means two things. It means the location and it means the dot, both. That's what mathematical physics has done throughout the ages. Okay, they blended things with concepts, and that's where they ran into trouble. Okay, that's why they got space-time, four-dimensional space-time, unimaginable. They don't care. It's four-dimensional space-time, and then you ask them, why does the Earth fly out of the solar system? Well, they said there's a depression in time. We have warp time. What the hell is that? Okay, why? Because they've turned time into a physical object. They blended the physics, the fishnet, together with a concept called time. They put them together and they said space-time. You got it, right? Yeah. That's how it's done. Okay, but it turns out this guy says lines are axiomatically defined. Are they? When I look it up, this is what I see, okay? You correct me if I'm wrong. Points and lines says axiomatically defined. And here you look it up, it says point and lines are undefined terms. Everywhere, I mean, these are from the Google. I just Googled points and lines, and everywhere you see undefined terms, point and line, and plane also. So all these are undefined terms, admittedly, by everyone out there, okay? So everybody essentially says that points, lines, and planes are undefined. So I don't know what this fellow says that they're axiomatically defined. Okay, but then after saying that these points, lines, and planes are undefined, they go ahead and they attempt to define them. Here it is. These are what you find for point. Point is in geometry is a location. It has no size. No kidding. How can it have size if it's a location? There's no such object called location. Objects can only have size, and these people are talking about the size of a location. And then they say a line extends infinitely. Well, then if a line extends infinitely, it's not an object. It's not a thing, because there's no object that is infinite. All objects are finite. In fact, it's a synonym of the word object to say that it's finite, meaning that a line is a concept. There's no physical standalone object called line, and yet they always draw a little line, right? And a little elongated rectangle to represent the line. And they say the line is one-dimensional, but yet what they draw is always two-dimensional. So the elongated rectangle. And wherever you look, you see this: location and size, location and size. Okay, all of them talk about location and size. And so that's what a point is. And the line, what is a line? Well, a line really is one of two things. It's either a row of apples or an apple that's moving down the street, okay, an itinerary of an apple. And both those notions are the line. And the mathematicians use whichever one they need at any given point in time, depending on the context. Okay, so we have a problem. We have a problem because we don't know what a line is, and it turns out the line is one-dimensional, and it's made of zero-dimensional points, which makes no sense whatsoever. So what are these people talking about? Well, it turns out the point is not even a point. It's in other words, not the dot that you're staring at. It's the location the dot supposedly represents. And a line is, again, one of the two things. It's either an itinerary or it's a row of apples. And so they use these concepts mixed with objects, and they put these pictorial representations of these concepts, and people confuse the pictorial representation with what it represents, the concept it represents. That's where the problem is. And again, it's because math and phys, they can never be reconciled. Mathematics has nothing at all to do with physics, and that's where the problem is. Okay, and people have problems understanding that. That's one of the first things you got to grasp. Okay, and another fellow says, no, I'm sorry. This is an outline of what I'm saying that mathematical physics has done over the years. They equated concepts with objects. That's what it is. And they say that an object exists is also equal to an object. Why? Because objects are defined as that which you can touch or see, and exists is that which you can touch or see. And that's why these words are synonyms. And that is not true. Not at all. Not in science. And what is a dot? It's location. They call it a point. Both of them. The dot and the location are called point. What is a line? An itinerary. It's also a row of apples. Okay, so a line is both. Surface, they equate it with plane. Number, they think it's a thing. No, a number is not a thing. Number is a verb. Number is action. Number is moving your arm up and down and counting apples or whatever you're counting. Number lines equal to coordinate, number line equal to dimension, number line equal to vector. All these are synonyms according to the mathematicians, okay? And that's not true. The coordinate, dimension, and vector belong to physics exclusively. Number lines belong exclusively to mathematics. Never the twain shall meet. And then they say that space is 3D. So they take a solid and they say 3D space. Yeah, sure. No, space doesn't have any dimensions whatsoever, and you should not confuse the black stuff in the night sky, that dark stuff, which they say is filled with dark matter and dark energy. You should not mix that with the object. It's the question of if you put your rubber ducky inside the bathtub, it displaces water. Well, the volume that it occupies you can say is the space, whereas the rubber ducky is what is 3D. The space is not 3D, okay? Because there is no such thing as 3D space without the object. Okay, and then we have the things of mathematical physics. They've turned everything into a thing, and these are all concepts. The force has turned into a particle. They talk about particles of different kinds of forces, the four forces of quantum mechanics. But what is a particle? It's a function. But then they have wave is a thing, energy is a thing, field is a thing, time is a thing, singularity, information, everything is a thing. And they start moving these so-called things around. And that's where they run into trouble, okay? So yeah, this is the issue. The issue is that what mathematical physics has done is reify concepts. And they use them back and forth. When they want to talk about the concept, they talk about the concept, and then they represent it with an object and move that object around. People think they're moving, they say, we're going to move love now, and what they're moving is a heart. Okay, we're going to move the point, and the point is the location. You don't move a location. Hopefully not. I mean, maybe after 10 beers. Okay, so here's the rationale behind the axis of mathematical physics. And this is where you really have to pay attention now, okay? Why is it irrational? Well, because they start out with a point that's zero-dimensional, okay? Why? Because it's really a location, meaning it's non-dimensional, not zero-dimensional, non-dimensional. No concept has dimensions, okay? So they start off on the wrong foot, but then they're going to construct their line with all these 0D points. They're going to say it's a 1D line. So we have a 1D line constructed of 0D points, which are not 0D, they're locations, meaning they're non-dimensional. So far we have nothing in front of us. But they put a row of apples, or they put a solid line across there, a solid elongated rectangle, and they say that's a line. And no, that's a two-dimensional thing, hopefully made of two-dimensional dots, right? That's what we have objectively in front of us. And they say, well, make believe. Make believe that it's one-dimensional. Make believe it's zero-dimensional. Well, I can't make believe because I cannot imagine zero dimensions, okay? No object is zero-dimensional. So when you talk about zero-dimensional object, you're talking about nonsense, okay? And that's the problem. We've had this all the way since Euclid. Okay? And they're still using these notions today. That's why you end up with a singularity, which is zero-dimensional. And you say, okay, you got nothing so far. And they say, oh, yeah, but that one moves stars around on the other side of, gazillions of miles away, so-called black hole. And you say, hold it, this singularity moves a star far away, moves it around itself? How did it do that? And forget about how they did it. Please show me a zero-dimensional singularity. Show me that it's an object to begin with. Because if you have a concept, how does a concept move a star? That's the question. Okay, and here we have, again, the 1D line can be a row of apples on an itinerary of one apple. Okay, and the axis is alleged to be a line, in other words, 1D line. That's how they define the axis since time immemorial. Okay, but then the question is the mathematical axis a row of apples or an itinerary of an apple? Which one is the axis? Well, I can assure you that they're going to be using the row of apples and not the itinerary of an apple. They're not going to, for every point, they're not going to say, okay, let the point in the center move upwards and create the axis, okay? And it's just an itinerary. And now the object that's going around, whether it's spinning or orbiting, that's going to establish its reference to an itinerary. No, they want you to believe at that point that the axis is really the row of apples, a solid line. Okay, they're going to have this solid line, but this solid line, keep in mind, is one-dimensional, made of zero-dimensional points. So there you have it. That's what it looks like. The one-dimensional mathematical axis, that's what it looks like nothing. So far, they have nothing in front of them. Why? Because they're not going to be interested in spin or orbit. They're going to be interested in distance travel, actually, not even distance, separation. They're interested in distance travel. And what they care about there is numbers and units. 5 meters, 10 feet. That's what they look at. They look at distance traveled by the tip of your measuring tape. Okay, so many meters, so many feet, so many yards, so many miles. That's what they look at. And so that's what they're going to be looking at. And they're going to use as a reference a one-dimensional line axis. Okay, and that's what they're going to base their spin, with respect to that. Okay, and yeah, mathematics is abstract, which is exactly the opposite of physics, which is physical. And what mathphysics has done, it's irrational because it's trying to merge the abstract with the physical. That's the issue. Okay. Okay, so what's the problem with the mathematical axis? Well, it's one-dimensional, and give me a second here. Okay, I'm back to normal. Okay, so what's the problem with the axis? Well, here's the problem with the axis. Okay, here's the mathematical axis. It's either a row of apples or the trip of one apple. And both of them are regarded as lines in mathematical physics. Okay, so it doesn't matter if you have a row of apples or the trajectory of one apple. Mathematical physics consider these two notions, which are irreconcilable. They consider them as lines. And that's what they call it. And that's going to be your axis, one of these two. And they're going to insinuate the axis is really the one on the left, the row of apples, because you can understand if you have a stick there that you can move around the stick. You can't move around an itinerary because it's like what's left after the apple's gone. Well, there's nothing there. The row of apples you can imagine because you got a stick there, but an itinerary you don't have anything left. Okay, so they're going to insinuate that the one-dimensional axis of mathematics is the one on the left, the row of apples. Okay. So what's the issue here? Well, I put the other day a two-dimensional stick because there is no such thing as a one-dimensional stick. And the problem there, the big problem there, and the reason these people never discovered this in the last 10,000 years, none of them, okay, is that we don't know if a one-dimensional stick spins, rotates, spirals, or whatever, orbits. Can a one-dimensional inexistent stick do anything? And even assuming, God is the only guy who can see the one-dimensional stick. Fine, so we'll take it up with heaven, okay? So God is looking at this one-dimensional stick. Can he tell? I mean, he's all knowing, right? Omniscient. Can he tell whether a one-dimensional stick, right, one-dimensional line is rotating, made of zero-dimensional points, by the way? Is it rotating or not? Well, you can't. You can't tell because it's one-dimensional. It's not fat. It's not thick. It has no width. So there's nothing to gauge whether the one-dimensional axis is spinning itself. That's why the mathematicians never discovered it. When they take a distance, they take the distance whether the stick is standing still or spinning. It doesn't matter to them because they're going to look at distance traveled from this one-dimensional concept. And again, spin is a three-dimensional notion that belongs to physics. Okay, we're talking about a phenomenon that objects can do. And these people are saying, okay, we're going to drive a stake, one-dimensional stake, through the object. That's going to be our axis, and we're going to gauge whether something is spinning with respect to that axis. Well, again, the issue of whether the axis itself is spinning or not makes a big difference, and there you see why. Here you have the two-dimensional axis. I painted, color-coded each side red and blue just to make a point, and that's that you have these two edges. And the distance of the ball changes with respect to those edges depending on where it is around that circle. Okay, so it's straightforward. And I do it with a 2D, I can do it with a 3D as well, like I did last week, okay? And so the issue here is that, if that stick, that two-dimensional axis rotates, it's very different than if it doesn't rotate because the distance from each point on that stick to the ball changes. You can't do that with a one-dimensional line, one-dimensional axis, because it has no width, no thickness, no nothing really. There's nothing there, and so you can't gauge whether it's spinning or not, the axis itself. And that's why they never discovered that. They only look at distance and whether the 1D stick, 1D axis spins or not. The distance is the same. Whereas with 2D and 3D, it's not the same. Okay, and again, spin belongs to the 3D world, not to the world of abstract mathematics. Okay, so this is where we have a problem with all this. And that's why they never figured out the definition of spin. For them, it's just a question of distance, and not a question of whether the axis itself spins, because they cannot even imagine an axis that is spinning or even standing still. You cannot imagine an axis, a 1D axis. Okay, so it's because they introduced this notion, this concept called the 1D line, made of 0D points, by the way. Rub that in whenever I can. It's because they introduced this notion and then translated that into physics. And they say, oh, the Earth spins. Why? Well, because the surface is moving around an axis. And the axis is 1D, made of 0D points. Rub it in one more time, So, no, there is no such monster as an axis, a 1D axis. If you're going to talk about spin, you've got to use 2D if you want, fine, just to make your point, just to make your argument, just so that people understand your argument. And better yet, 3D. You put a cylinder in there. Then you say, well, does the cylinder stay put, or does it also twirl with the object, like in the case of the moon? And so here's the conclusion to all that. Here you can see why the moon doesn't spin. And you see the moon compared against the moon, left to right at the top. And if the axis moves around together with the moon, with the surface of the moon, then it's not spinning. Okay, so I don't care if it takes 27 days to go around the Earth, and as people say, it rotates once around its axis. No, it don't, because if I put a stick in through the moon, a 3D stick, if I drive a stake right through the moon, the stick is gonna move together with the surface. Then it's not changing its distance, the surface to the stick at any point in the stick, and so it's not rotating. It's not spinning, which is the correct word. In the other scenario on the upper right there, that's wrong. And that's not what the moon does. The moon does not, the surface of the moon doesn't, any point on the surface of the moon doesn't change its location with respect to that fixed axis, to any point on the axis. Okay? And then you see the moon versus the Earth. The Earth does spin because the axis of the Earth is fixed and the surface moves around a fixed stick. And so the distance of any point on the surface of the Earth changes with respect to that axis, to any point on the axis. And in the case of the moon, it don't. That's how simple it is. Okay? Do you agree? I don't care if you do or not. Science never cares whether you agree and whether you believe. Okay? In science, we try to understand the concept, and if you have a better concept, then you get in the ring with shield and sword and defend your concept. That's the way it works, okay? Very simple. Okay, and here we have another fellow. He said, is the thermosphere 5,000 degrees or not? This is what NASA claims is the reason why we can't get past low Earth orbit. I guess one of these moonies who believes we never went to the moon because we would go through the thermosphere and fry. Astronaut would, maybe the rocket makes it through, but not the astronaut, because he would be fried at 5,000 degrees. Okay, and please explain the physics of this layer of the atmosphere. Okay, let's explain that very quickly, very simply. Okay, this is what this all missed. Okay, the thermosphere. Okay, it extends up to about 1,000 kilometers above the Earth. The temperature is about 2,500 degrees C. Maybe around 4,500 Fahrenheit. But there's not enough gas molecules to transfer the heat to you. Imagine if I take a match. Can you be burned by a match? I mean, can you put your finger there on top of that flame and stay there, for 2 hours, assuming the match stayed lit long enough? No, it would burn your finger. But see, I can throw that match at the astronaut, and it's not going to burn him. And that's the issue there. You don't have enough matter. You don't have enough atoms. You don't have enough molecules at 1,000 kilometers above the Earth. Even though it's hot, there's very few molecules to really burn you. Okay, so an astronaut could just be outside his capsule at 1,000 kilometers above the Earth, and he would not fry, because even though the temperature of each molecule there could be as high as 2,500 degrees, there's not enough material there to burn him. Okay? Aside from the fact that at that point they usually go inside their rockets, okay, inside their capsules. Okay, so hopefully you understood that. Let me get these out of here. And then finally another fella says, I like this one. Another Moonie says, we never went to the moon, right? Why? What's his argument? I think that's what he's proposing. I think that's what he's saying. We didn't go to the moon. Why? Well, he's saying that, went through the other side. Give me a second here. OBS has that thing where you can overshoot and it takes your thing out to the other side. He says, Mount Everest is littered with hundreds of bodies. The moon doesn't have one dead body. So I guess he's looking for proof. If we find a dead body on the moon, then it means we did go to the moon. But if we don't find a dead body, then we didn't go to the moon. You need to look deeper into the Moonies' claim. What can I say? People look for proof, evidence that we went to the moon. And no, we don't do proof or evidence in science, first of all. Okay, and you can make an assumption. Say, let us assume we went to the moon, and explain the theory with that. And you can explain many types of theories with that. One could be gravity and whatever. For example, you could say, why did the hammer and the feather, when they dropped it on the moon, why did they fall at the same time? And so you make the assumption, let's assume we went to the moon, we threw these two things, and this is what we observed, and now you try to explain the gravity, so you could use that for anything. But this belief that people have, or unbelief that we went or didn't go to the moon, it really plays no important part in science itself, in physics. Okay? So do not harp on it. But I can tell you that I doubt very much that a program that has lasted at least since the 1960s, that's 60 years now, and thousands of people working year after year after year, decade after decade, and that all that is a hoax. This is not like JFK's assassination. This is not like 9/11 that happened in 1 hour or whatever. This is something that's gone on for years. You can go to Cape Canaveral, you can go to Houston or Jet Propulsion Labs, and you can go there and find out what they're doing if they let you in. And they send these rockets, and you don't even have to be inside there. Like I said, you can take your telescope, and you can take your camera, your super duper camera, and watch how that rocket goes out. Right? And you can film all of it, and you can see that it goes out into space. In fact, the Skylab is still rolling around the Earth, and if you have a good telescope, you can see it. So what is that thing up there? I don't know. Maybe angels?